So what you see right now is a simple web application hosted in Kubernetes on AWS. It's publicly available. It's written in PHP, and it serves only one purpose. It's designed to upload resumes. But it has one little drawback. It uploads files directly into the web directory in a PHP server, which means that any file that has been uploaded can be executed as a server-side software component, and it is classified as a vulnerability. Okay, so let me show you what I mean. There is a upload form. I'm gonna type in my name, my email, and it's instead of choosing a PDF resume, I will choose web shell PHP file. Click open, and as soon as I click submit, file gets uploaded to the web directory. And now what happens next? I want to execute this file. Okay, so I navigate to this URL, and what I see prompt, and it looks like it asked me to, to type some command. Shall we test it out? Sudo ID, execute. Excellent. I've got a successful response from the remote system, and now I can start compromising a cloud environment from the inside. So knowing that application is hosted in one of the cloud providers like GCP, Azure, or AWS, they all have metadata endpoint, instance metadata endpoint, which is 169.254, 169.254. This endpoint is used to hold metadata about instance or virtual machines, and also it can respond with security credentials. The metadata is well documented in AWS documentation, so I'm going to ask for security credentials navigating to this URL.
Vasily, the credential that you show at the moment on the screen, are these the temporary ones, or are these the one that malicious actors will use through the whole attack?
That's right. These credentials are temporary, and I want to be very fast, so I have like several minutes to do the job.
Okay. Any AI maybe to help you with this?
Of course. So I asked ChatGPT to generate me a command that I'm going to execute. And what the command does, it nicely outputs export commands.
Oh, wonderful.
So I can copy and paste to the terminal, hit enter, and then I want to validate with get caller identity if credentials let me do something. And I've got successful response from get caller identity, which is basic. You can imagine user info endpoint, right? If a request is legitimate, you get successful response with instance ID, for example. Okay.
Wonderful. So we're in.
We're in, yeah. And from this point, you are only limited by your imagination. What can happen next? What we do, we use Ansible script to automate user persistence. We want to leverage any possible option in IAM, identity and access management in AWS, to persist. We will create IAM user, IAM role. We also set trusted relationships with a source account and boss account controlled by attacker. And also we will be using even sophisticated ways to set persistence using IAM identity provider and role anywhere. So do you want to see in action?
Of course, yeah. Let's keep on rolling. It's interesting to see how long does it take to actually gain privileges and feel yourself in a God mode within AWS. So you already initiated?
Yeah. So the process has been started, and let's see how long it takes.
What do you think? Your
1
prediction?
minute.
1 minute? Wow.
I think so. Yeah.
That's amazing. I mean, what usually happens during this period of time for the team that sits on the defense side? I guess they do not even suspect that you are doing something because you have a valid credentials, because you managed to log in using these valid credentials. Maybe it was only a geolocation that might reveal your trigger security alert and reveal something.
Well, most likely they won't see anything, especially if they're using cloud native services. We will discover it in a few seconds. Just let me get it done. So it took 64 seconds.
Oh, wow. Wow. Amazing.
Do you want to see AWS Management Console, what we just did?
Of course. Yeah, it's really interesting to see how it's been reflected within AWS environment. What actually happened? What did you modify? What did you change? What are the typical ways for malicious actors to move?
So I went to identity and access management to show you that persistent user has been created, and also credentials has been activated.
I will say that's probably the easy one. Each and every security team will be looking for the new user creation role, right?
Yep, and also they will be looking at roles. So
Okay.
you see that 3 roles has been created different, like with trusted relationships, without trusted relationships. And also the most interesting part, and I think I was ignoring roles anywhere, by the way. I didn't click manage, but it was exciting to me learn about roles anywhere. So we also try to persist creating roles anywhere. You can see that the time of creation. It allows you to communicate with AWS API by signing requests offline. So you don't need any credentials. You just deploy your certificate to roles anywhere, and that's it.
Oh, okay. So you mean like the first thing you might want to do is to create a user, but it's too obvious. You can create a role. I've seen that there was like 42 roles being created in your environment. Is it a typical number for AWS environments, or like what number of roles do you usually see with medium, large scale enterprises?
When you start building cloud native application, each service requires its role. Lambda function, Docker container, like EC2 instance, or whatever you use, it requires you to set up a role. So this number can be increased up to 1,000 roles.
Oh, wow.
And it's hard to monitor each role and each aspect of identity in AWS in cloud environment.
So it's easy to miss one if you look on 1,000, and you can probably name it in a way that one of the DevOps team guys will not be deleting it. Oh, right, yeah,
Like,
do not delete,
do not
or
delete
like
it.
do not touch or something like this, or important thing. Yeah, that's probably.
And also one challenge is that when you use multi-account strategy, you have several, like thousands of roles. Quite a challenge indeed.
Okay, so users roles, creating identity providers. These are the most common ways for malicious actors to persist within AWS.
Excuse me, some technical issues. Can you ask it again?
So creating users roles, identity providers, is this the typical ways to persist within AWS?
Users and roles, yes, but roles anywhere and identity providers is, like, I would say, more advanced techniques to persist in the system.
Oh, okay. Okay, good. I think we also had a poll to our attendees today to check if they knew about this. So it would be good if you could share your thoughts with us, so we understand if it was something new to you, or maybe that's something that you already know about it. As our attendees answer the question, if working on the defense side, if you do not have any SIEM, any additional security tools, and use only cloud native AWS provided tools, how would you probably suggest to spot this type of an activity?
Well, let me start. By default, you would want to check out CloudTrail.
Oh, give me a second. We already have like a lot of answers, so maybe we can just see that most of our attendees knew about IAM users and roles. 80 to 90% of those, but roles anywhere and identity providers was definitely something new. And we see that 40% of all of our attendees already participated. So if someone else wants to add to this, please go ahead. Would be interesting to see what you guys think about it. Vasily, go ahead, please. Sorry for breaking you.
So CloudTrail is by default service that enables you for monitoring. You can see API calls. You can, but you need to manually go in CloudTrail and decide whether it was a legitimate call or it was from a malicious actor. So it wouldn't be helpful. Additionally, if you want to set up cloud native services like GuardDuty and Security Hub, you also can go this way. But what is interesting to know is that GuardDuty would generate finding like this one, instance credential exfiltration outside of AWS. This is what we've just done. It would notify you in 20 minutes. So this is a typical time to identify such activity. But again, you need to enable GuardDuty.
Did I get you right? So in order to receive security alert within the GuardDuty, first of all, you need to enable this alert. And second, it takes up to 20 minutes to receive this information within the console.
Exactly, due to event-driven nature of the cloud and GuardDuty service itself.
Oh wow, that's a lot. I mean, 20 minutes and taking into account we had 64 seconds to gain privileges. You still have almost 19 minutes to do whatever you want, to exfiltrate data, to download things. Wow, that's amazing. I mean, that's definitely a lot of work that defenders need to do in order to protect their environment. Wow. I mean, it doesn't show up yet. No alerts.
Isn't yet. Yeah.
Good. Then let me share my screen now. I would probably want to jump into UnderDefense MAXI portal because from a security perspective, the UnderDefense MAXI portal already detected this activity that Vasil mentioned. We have the direct connection that pulls data out of AWS, and you will see in just a minute threats and incidents tab with information about security alerts that already pollute all of our systems. You see at least 4 security alerts that triggered Elastic Cloud SIEM. That's where we pull all the information in. And there was group creation. That's what we did. User account creation, again, role creation, and access key creation or activation. Let's just jump to one of those and see what type of information does UnderDefense platform provides and what it actually does. So we do our best to give you as much valuable information as possible in a small little window. So no overwhelming, basic information about the severity, about the status of this alert, about the log source. You see that there is a section that is called 5Ws. So giving you an information about when the security alert happened, what was the reasoning, who it belongs to or associate with, where it happens, and why it actually happened. So what was the main cause for this security alert to pop up? There is a final verdict here. It's currently unavailable because no one took legacy working on this at the moment. But you see that it took only 3 minutes and 15 seconds for UnderDefense MAXI portal to detect this activity and pull this insight of this platform. We have the impact, the possible impact, giving you information about why it's important, and our recommendation of what needs to be done in order to mitigate this. On the right side, you see the timeline that gives you a holistic view from the very beginning to the end when it's already defined, so when the incident is closed, with all the steps that have been taken. So the alert generated time, the enrichment with the playbooks and the AI, the incident creation time, and when the security analyst kicks in, you will have the information about what was done and what is what is done within the security incident on the background as well. So UnderDefense portal gives you, as I mentioned, a lot of options to respond right from this platform. There is a respond button on your right and gives you a possibility to respond, to make some actions. We automated a lot of things, as I mentioned at the very beginning. So this is just a short example. Depending on data sources, you can activate different playbooks and have the information and processes speeding up as fast as possible. Again, I wouldn't want to spend a lot of your time on UnderDefense MAXI, but there is a dashboard that gives you a holistic view of security incidents, the affected systems, the trend analysis for different incidents that happened, the SLA, so the response time for different security severity incidents, and some impact summary highlights. All of the other information is being generated and sent into the reports section.